name's Eddie. I'm talking about the Harvard Explorer approaching mathematics as exploration. We meet at a university noted for knowledge, a city noted for progress, in a state noted for strength. And we stand in need of all three. For we meet in an hour of change and challenge, a decade of hope and fear, in an age of both knowledge and ignorance. The greater our knowledge increases, the greater our ignorance unfolds. We set sail in this new sea because there is new knowledge to be gained and new rights to be won. And they must be won and used for the progress of all people. There is no strife, no prejudice, no national conflict in outer space as yet. Its hazards are hostile to us all. Its conquest deserves the best of all mankind, and its opportunity for peaceful cooperation may never come again. But why, some say, the moon? Why choose this as our goal? And why, they may well ask, climb the highest mountain? Why, 35 years ago, fly the Atlantic? We choose to go to the moon. We choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard. Because that goal will serve to organize and measure the best of our energies and skills. Because that challenge is one we are willing to accept, one we are unwilling to postpone, and one which we intend to win. So, why spend a minute of a 7-minute Teach Me presentation quoting JFK? I'll tell you why. The theme of this conference is promoting motivation and engagement. And that's exactly what JFK was trying to do. He was motivating and engaging an entire nation. And he knew that exploration is a key driver to the human spirit. We see intrinsic value in going places we've never been before. And mathematics is no exception. Mathematics is so exploratory by its very nature that even when mathematicians run out of things to investigate, we invent new worlds to explore. That's what maths is all about. Now, here's a question I want to pose to you. What is the chief metaphor that you and your students have when you walk into your classroom? What are they thinking? What are they picturing? Is it, for example, a room where they are to repetitively master skills? Or perhaps it's a place to memorize arcane facts that have no relevance to real life, like this guy memorizing 59 decks of cards. Wouldn't it be great? Wouldn't it be wonderful if our students walked into our classrooms and if we did and thought to themselves, what are we going to see today? Where are we going to go? Because that kind of motivation is what pushes people to climb mountains. It's what pushes people like James Cameron to go to the bottom of the ocean. That's his submersible, going to the Mariana Trench. He had to work out how to go 12 hours plus without going to the bathroom. How long do your year 10s last on Friday afternoon before they need to go to the bathroom, right? And really, there's not that much of a surprise because this is kind of how we teach maths, right? We sort of present it as this monolithic structure of accepted wisdom, and this is the way it is, and you have one explanation, you go to the next one, and the next one, and the next one. Why? Because that's why. But that's not the way maths was invented. It's not the way it was. Dan Mayer, he put this graphic together. He says, maths class needs more. What the that moment, that's what drives. That's why I want an explanation. That's why it has value to me. So, that's all well and good, Eddie. But what does it look like? What does it look like? Let me show you some examples. And I hope some of you have seen these before, but the whole point is to explore these through the lens of exploration in the maths classroom. So, have a look at this guy, right? Let me show it to you in motion. That might be a bit easier. So, here's a triangle, right? It's a triangle. It's 5 units high, and it's 13 units across. So, it has an area of, we're asleep. Okay, 32 and a half square units, okay? But all you do is rearrange it, and suddenly there's a missing square. Okay, it's starting to get a bit weird now. Have a look at it. Stop moving. Why is that the case? Okay, now you can just tell them this is the reason why, right? Do it with chocolate if you like. That's very motivating, and it comes in squares as well. But why not rather get your students to take this picture, cut it out, fiddle? What happens when the triangles are different sizes? Get toward an explanation through exploration rather than exposition. And even if you do have to just say it, this is why. You do the proportions. If you really want to be fancy, you do inverse trig. You find the right angles, which are not matching. Even if you have to do it by exposition, exploration gives you a reason why you want to go there. What about these guys? Right, so you get them to make a loop of cardboard, just a normal loop, nothing fancy about it, and you get your scissors out and you say, okay, let's cut it up. What do you expect to happen? Unsurprisingly, you get 2 loops. Of course you do, right? But then you tell them to add a half twist, right? You don't have to tell them what it's called yet. And then you say, okay, let's cut it up, folks. Let's do the same thing. And you just sort of merry going along, and you think, of course I know what's going to happen at the end, assuming you know how to cut paper. And you get there and you say, okay, you ready? You ready? Make a prediction. And then you get, wait, what? That's that moment. That's what you're after, right? If I had more time, I'd show you what happens with a double twist, right? It's lots of fun and you can explore, and so can the kids, right? The great thing about exploration is that even the dead ends have value, right? As soon as your 9s and 10s learn about power of power and fractional indices, show them this, right? Say, look, square root minus 1. You know it doesn't exist, right? Of course not. I mean, you guys do, but they don't, right? So that's the power of a half, right? Now, half, 2/4, they're the same, aren't they? Aren't they? Yeah? Power of power, okay? Have a look at that. Does it make sense? Of course it makes sense, right? Hold on. Wait. What just happened? What's 1 power of a quarter? It's the 4th root of 1, right? And they think, well, there's only one number I know of that you multiply it by itself 4 times, you get 1. It's 1, right? And so they, what? Now you guys know where the problem is, right? Right? But when you, come talk to me later. But the whole point is, this gets to what a deeper geometric meaning of what, I mean, you don't have to go to roots of unity with your 9 and 10. You don't have to, but you can. Really quickly, they all ask questions. They naturally ask questions about 0. 0 breaks everything. Don't discourage that. Say, that is a good question. That's a good question. Let's think about that. See if you can come with an answer. Does it make sense? Can you argue? So, let's finish, because I'm over time. 3 suggestions for you. You need to commit to something, encourage something, and go and do something. Number 1, find these things. They're called books. They're called books, right? If you're really, really curious for more, you should go and find Norden's work on the Pi collection.